Always the fourth row.
Yes. No. The fourth row is for when you're choosing when the total number of chairs is 4. Okay. So all right.
Does that always be 111 per one?
Yes, we'll always start with 111. Okay. So Stephen, if you're listening to this, what you just missed was the Pascal's triangle. I'll explain this part again. So. Okay, actually I'll go through, I'll leave the Pascal's triangle here. I might do another explanation a little bit later and see how that is relevant to finding the probability in what we're about to go through. Okay, 15a is the idea of, let me open up textbook here. Okay. So 15a is about, it's a very, very long chapter. Introduction to Bernoulli sequences and the binomial distribution. So this is only the start of like a series of chapters that ultimately lead to what I told you guys earlier, that is a really interesting topic in Unit 4. Okay, what is a Bernoulli sequence? So it's talking about, okay, so a Bernoulli sequence is a sequence that has these following properties. Okay, each trial results only in 2 outcomes, success or failure. All right, so the first point is each trial only has 2 outcomes. Okay, success or failure. So success is normally denoted with a number 1, or failure, which is denoted with number 0. Normally, okay. Okay, hang on. Okay, success or failure. So for example, if you flip a coin, right? If you flip a coin, you either get a head or a tail. But right now, it's not a Bernoulli distribution. It's not a Bernoulli sequence, because what is success and failure? Head and tail, how do you know? So you need to define success. So success, right, equals to getting a head, for example, right? You need to define the definition of success first. And then the probability of success, or let's say probability of success, right, would be equals to, in this case, flipping a coin, that would be 1/2, right? Yeah, and then the probability, and this is normally just written as the lowercase probability, lowercase p, okay? And then the probability of failure would be also 1/2 in this case, for getting ahead, right? And probability of failure is normally written as 1 minus p. Why? Why is it 1 minus p? Because if the chance of success is 1/2, failure is just all the other scenarios. Okay. Now, another example that might better illustrate this idea of just like a like 2 outcomes, success and failure, is roll a dice. All right, roll a die, a 6-sided die. Yeah. So you have to define success in some way. So let's say we define success as getting a 4, for example. Right? So if you get a 4, you get a success. So what's the probability of success? The p-value or probability of success is 1/6. Yes, that's right. Okay. So okay. So probability of success would be p would be 1/6, and then probability of failure. How would you calculate this one?
Just 1 take away 1/6.
Yeah, it's 1 take away 1/6. 1 take away p, which is 5/6. Right? Okay. Now, the next part is the important one here. Okay, okay. The next part. So now that you understood this one, the next few condition is only to define the Bernoulli sequence. So the next one is the probability of success is constant. So PR of success is constant for all trials. Okay. What would be a scenario where the probability of success is not constant? What do you think, Peter?
Oh, for example, like you're picking balls in the bag, right? And
yes.
Different colors.
Yep. Yep, that's right. If you take out balls from a bag and then you don't replace the ball every time you pick a ball out, the probability of success changes. All right, so that wouldn't be a Bernoulli distribution. The other one would be independent trial. So the last one, the trial must be independent. Okay, the trials are independent to one another. So what it's saying is that when you flip a coin, the chance you're getting ahead is the same as when you flip the coin again like 2 minutes later. It doesn't change. Yeah. So that's what it means by independent trial. So when you repeat the trial, it doesn't change. Like rolling a dice also doesn't change. Okay. Yeah. So those are the initial bits about a Bernoulli distribution. Next is the concept of a Bernoulli random variable. Okay. Bernoulli random variable. So the outcome from a Bernoulli trial is represented by a Bernoulli random variable. So this is what I said earlier, where the result. Okay, so let's say the variable y. Let's say the variable has the symbol y, right? And then the distribution table looks something like this. So first, y has only two scenarios, right? One for success, 0 or failure. Okay, and then the probability that the random variable take one of these values. So this is writing it this way just means this is like probability of success, right? And then this would be the probability of failure. So instead of having to write this long thing, you just use the table to say, okay, the probability that the random variable y take the value of small y is whatever that is. So this one would be the lowercase p that I said earlier, right? Lowercase p is normally the probability of success, and failure is 1 minus p. Okay, make sense so far? Yeah? Okay, now the main thing is the binomial probability distribution. Okay, binomial probability distribution. The word binomial is referred to the Bernoulli random variable, right? Bi means two. Binomial means there's only like two results, like success or failure. Okay, and a distribution is the distribution of the probabilities. So what does that mean? Okay, all right. So if you throw a die 4 times. Okay, throw that 4 times, and then success. Let's just say you are at the casino, right? And then they go, you have enough money to play 4 games. That's what it means by throwing a die 4 times. Right? You can see the die is being thrown 4 times. And success is, let's say if you want, if it's just a simple one, they roll 1 die, and success, and you bet on number 6, right? Success is equals to getting a 6. Okay. So now the question is, what is the probability that, okay, so in this case, right, let x be the number. So remember, so note that this letter here is a capital X. Capital refers to the random variable. Remember that what we were saying earlier? It's a random variable, right? It's that variable that can take any value. So far we've learned like small x is like it could take any value. Now the capital X is a random variable that can take any result, any event.
So
always random variable is always capital. Yeah. So let capital X be the number of successes or the number of 6s in the 4 throws. Okay. The number of 6s in the 4 throws, because obviously you want to win all the time. So you want to get all the 4 throws, you get 6. Yay, got some money from the casino, and then 6 again, and then 6 again, and then 6 again. So what's the chance of that happening? So let's say we're talking about what's the probability. So nominally, it's like chance of getting all 4 successes. Right? So all 4 throws are 6s. What's the chance of that? Now, this one is represented in mathematical form as probability that the variable, the number of successes is equal to 4. Okay, make sense? Yeah, 4 successes. So PR x equals 4. Now, what's the probability of getting 4 successes? What's the probability of getting a success? What's our lowercase p? P equals to?
Forget getting 1 times only.
Yeah, the chance of getting a success in a trial.
Oh, it's 1 for 6.
Is 1 over 6, right? So the probability of success is 1 over 6. So 4 successes means that the first time you throw it is 1 over 6, it is a 6. Alright? Or let's just, maybe it might be confusing. I'll change the success to be a, if you like, number 3, for example. Right? Okay? So if you bet on number 3, you want all 4 times to go 3, 3, 3, 3. That's like the best case scenario. But what's the chance of that happening? So 1 over 6. And then the second throw is also a 3. And the chance of that happening is 1 over 6. And you have to multiply because you're saying they happen at the same time. You see, it's relevant to that tree you're doing at school. Yeah, so they're doing a recap to lead to this topic. And then the third time is also 1 over 6. And the fourth time is again 1 over 6. Right? So the chance of getting all 4 successes is 1 over 6 to the power 4. We use a calculator for this one. You always need to use a calculator for, almost always, for these questions. Okay, so 1 over 6 to the power 4 is 0.000772. I'm going to a lot of decimal places. And this is roughly equivalent to a 0.07% chance. Okay? 0.07% chance. It's like it's saying out of like 10,000 games you play, each game you roll the dice 4 times, only 7 out of 10,000 would actually, like be 4 out, 3, 3, 3, 3. 3, 3, 3, 3, yeah. Does that make sense? Yeah. So that's not a very reasonable bet, right? You shouldn't be expecting like to win to win in all of your 4 bets, right? Because it won't happen that often. Okay. So this is a chance of getting all 4 successes. But what if we're talking about, okay, so let's say we're a bit more reasonable, right? So you just want to win at least once, or just 1 time, right? Chance of getting 1 success. Okay, so you don't care out of the 4 games you play, it doesn't matter which one, as long as one of them wins, you're happy. Okay, so this is equivalent to the mathematical formula notation that PR x equals to 1. So now we're saying we only want 1 success. Okay, but you gotta think about what if out of like the 4 games, right? You could either get a so first you might get a success and then fail. That's one scenario. How many scenarios are there out of the 4 games? You get only 1 success, right? This is scenario number 1. There's scenario number 2. You can see where I'm going with this. Yeah. Right? And then scenario number 3, the first 2 games you lost, but then the third one you won. And then scenario number 4, lose, and then you won in the last game. That's it. That's all the possible scenarios. Yeah. Right? So for each of these scenarios, what's the probability of this happening?
1 over 4.
1 over, it's 1 over 6, right? Because you win. So that would be 1 over 6. Times you lost, so that's 5 over 6. And then you lost again, times 5 over 6. And then you lost again, times 5 over 6. Okay? Yeah? So that would be roughly, I'll put this over here, giving myself a bit more space. So that would be 125 over, I think, 1,296. I said that number there, right? So what's the chance of event like scenario number 2 happening? You lose, and then you win, and then you lose, and then you lose. So it will almost be the same, but not exactly the same, right? Because the first time is actually you will lose, so that's 5 over 6 of the chance that you will lose the first game. And then the second game you win. And then the third game and fourth game, you lose again. What's the final answer? It's still the same thing. Yes, 125 over 1296. So you can see, because the structure is the same, it doesn't matter where the tick is, the answer is still going to be the same. 125 over 1296, and this is also 125 over 129, well, that should be 696, right? Okay, so you see this probability of getting one win technically is based on this ratio here, where it's like one of them is a win and then 3 of the other ones are all losses, right? It's basically that first group of numbers there. Does it make sense? Yeah, but there are 4 ways that you can win, so you have to account for that by timesing it by timesing that probability by how many ways are there for you to win, to get this scenario where you have one success, exactly one success out of 4. Make sense? Yeah. So 4 represents 4 ways, and then this is the probability of one event happening. Right, of the event happening just once. Does it make sense?
Yeah.
Yeah. So now how do we get that number 4 then? Let's just say we consider the next question. The next question is, okay, let's say you're getting a bit, and if we were to calculate that, let's see what the actual number is, right? So 4 times 5 cubed over 6 power 4. Okay, so this is 0.386 or roughly 39%. So note that I'm writing the other, like the percentage is only for you guys to have an intuition on what the number means, okay? But slowly I will stop writing that and just write 0 point something, because you guys will always leave your answer in 0 point something, okay? So 39% or 0.386 is pretty good, right? It's a pretty good chance of you getting one success, right? Okay, it's pretty good chance of you getting that. So let's say if you get a bit greedier, now okay, let's see what should I be expecting to get 2 winning games out of the 4. Chance of getting 2 successes. Okay, so this would be PR of x equals to 2. Right? Okay, so let's just say if we don't want to list out like this whole scenario over here, right? Because that's going to be a little bit tricky, but can we start off? So it will be like however many ways and then times by what's the base probability of this event happening. 2 successes means you will get 2 successes. So there will be 2 of the 1/6 in the probability. And then you fail how many times? 2 times. So there will be 2 of the 5/6 in the probability. Does it make sense? Yeah. Or maybe actually I'll write it this way. So it'll be 2 of the successes and then 2 of the failures. But then you need to multiply by how many ways, right? How many ways are there to have this arrangement? Okay. So then that would be 1/6 everything power 2 times 5/6 everything power 2. Okay, all right. Now, how do we count this? So this is when the Pascal's triangle comes into play. Okay, so Pascal's triangle. I'll do a bit of recap here for you, Stephen, if you're listening to this. Pascal's triangle. It starts with 1, 1, 1. Okay, it starts as a triangle 1, 1, 1, and then every row after that it starts with 1 on 2 sides always. Right, always starts on 1 on 2 sides, and then the number in the middle will always be the sum of the 2 numbers directly above it. So it'll be 1, 2, 1, and then 1, 3, 1, and this will be 1, 4, 6, 4, 1. Okay, here, make sense so far? Yeah, we've just gone through this one. So what does that mean by this Pascal's triangle? So here we are looking at, okay, what are the way of getting 2 successes? All right, 2 successes out of how many trials? 4. Okay, so this is 2 out of 4.
Yeah.
Right? So 4 means it's the 4th row. It's the 4th row of the Pascal's triangle. I'll just explain how to use it. So note that Pascal's triangle start with the 0, right? This is row 0, and then this is row 1, row 2, row 3, and this is the 4th row, right? Row 4. Okay, that's the row that we're interested in. Okay, so it starts from 0. So the easiest way to remember which row it is just to look at the first number. Okay, if it's 4, that's the 4th row. Right, that's a row for choosing when you have 4 trials. So out of 4 trials, what are the possible results you can get? You could get 0 successes, right? And then 1 successes, 2, 3, or all 4 successes. So remember, it also starts from 0 again, because technically, when you throw the dice 4 times, there's a chance that you don't get 3 at all, right? You get 1, 2, 6, 4. Yep. That's a all failure scenario, right? So you could also get 0 successes. And in the notation, the combination notation looks something like this. So out of 4 trials, 0 successes. The second one, 4 trials, 1 success. 4 trials, 2 successes. 4 trials, 3 successes. And 4 trials, all of them have succeeded. Okay? So this one is just telling you how many possible ways there are. So for out of 4 trials to get 2 successes, there are 6 ways of doing that. Number still small, so we can actually check it out, right? So let's say the first scenario will be success, success, failure, failure. And then we keep the first one, we move the tick over once, keep the first one, move the tick over again, right? That covers when the scenario where the first one is a success, and then if it's a failure, and then success, success, failure, failure, success, failure, success, right? And then after that would be failure, failure, and then the last 2 are successes. Okay, so that's scenario number 1, 2, 3, 4, 5, and 6. There are 6 ways. All right, 6 ways to arrange the scenario so that you have 2 successes out of 4. Okay, so that's an example of proving the results from the Pascal's triangle. So now we know there are 6 ways of doing that. That means in the probability up here, there would be 6 ways of getting 2 successes and 2 failure.
Yeah.
Yeah? And that's it. Just gotta punch that into the calculator. Or sometimes, in this case, you might be able to work it out by hand. So that would be 6 times 1 squared is 1, 6, and then times 5 squared is 25, and then the bottom will be 6 power 4. And then you can cancel one of the power, 6 power 3, so that will be 25 over 6 power 3, that will be 36 times 6, that's 260. Okay, if you were to actually calculate that, it would be roughly 0.1157, or roughly about 12%. Okay, so yeah, as you can see, it's getting a little bit lower, right? Before the chance of you getting 1 success, yeah, is a lot higher than getting 2 successes. And when you think about it, it makes sense, right? The chance of getting a success is only 1 out of 6. So the more successes you want, lower the chance of you actually getting that result.
Yeah. So the only way that we can figure out like that number is 6 is only using the Pascal triangle.
Yes, or your calculator.
Or the calculator.
Yes. So this notation here in the calculator, there is this is 4 choose, or put it as out of 4 choose 2, right? And this is NCR in your calculator. It's NCR. It's N is the number, so 4C2, right? Out of 4 you choose 2.
Oh yeah, I've seen that one. Yeah.
You seen this one? It looks something like that, I think.
Oh yeah.
Yeah, so you use NCR in your calculator, and you can just find the combination in your calculator.
Yeah.
So the Pascal's triangle is for a tech-free question. You might get this as a tech-free question. Yeah.
Next exam.
For the next exam, yes. For Unit 4, you will get one of these questions. It's either tech-free or tech-active, but you will get one of these questions.
Is this a big topic?
This is a small topic in Unit 4. The big topic comes in later. So Unit 4 has chapter 15, 16, 17, 18 as a probability. And after those 4, there's still, in this textbook, and after those 4, there's still 1 chapter on second derivative and 1 on trigonometry. So 6 chapters. In this textbook, there's 6 chapters in total. Yeah. So 4 are probability, so and then the other 2 are separate ones. So that's why about 2/3 of the exam will be on probability.
Yeah.
And this is one, this concept is 1 out of those 4 chapters.
Yeah.
The easiest one.
Easiest.
Yeah. Okay. It's the easiest one, but it sets out the concept, the main concepts for the hardest one. So when you get to the hardest one, it doesn't feel as hard.
Yeah.
Okay, all right. So okay, so now we have gone to this point where we could calculate the chance of getting a certain number of success out of a certain number of trials. Okay, and now I think I will use one of the actual example to go through. Okay, all right. Okay. Actually, okay. The next part would be let's try to derive the formula. So far we have seen what's the probability of getting, let's say, 2 successes out of 4 trials, right? So this would be, so what we did earlier, so 4 trials, 2 of them will be success, and then the probability is 1/6 because 2 successes, power 2, times by probability of failure, which is 5/6, and there will be 2 failures. Okay, now let's see if we were to change this number a little bit. So if you want 3 out of 4 to be successes, what would that change? This one would turn into 4/3, right? Yeah, and then the chance of success, you always have the 1/6 because there will be some sort of success, and then like there will be a scenario for failure. Yeah. So 1/6 and to the power of 3, because we're talking about 3 successes here. And how many? What's the power of 5 on 6? Power 1, right? Because out of 4 trials, 3 successes, 1 failure, right? So if you can actually literally just punch this into the calculator and get the answer. But what I'm trying to get here is the get to the formula. So generally, right, the general formula. Okay, so generally the probability of getting a certain number of success x. Yeah, so we've looked at 2 and 3, right? But if it's an unknown number of success, let's see what that actually looks like. Maybe I'll change this one to red. PR of getting an unknown number of success. Now what would that be? So the formula needs to start with how many trials are there. So what is that? What's the notation for that? That would be n. Okay, so n equals to the number of trials. Like in the case before, we threw the die 4 times.
Yeah.
Okay, so n is the number of trial, and then remember we said earlier the probability of success is p, right? So p is the probability of success. And before, the probability of success was 1/6 for the die example, right? Rolling a 6. Now we'll use the general formula. So P, the probability of success, and let's say if we're supposed to success x time, right? That means out of n trials, you want x successes. Yeah? And then if there are x successes, then you need to multiply the P by itself x times. Yeah, make sense? Yeah? And then after that is you need to multiply by the probability of failure. And what's the probability of failure? Probability of failure is 1 minus P. Right? This is only the success or failure. If success, let's say if P is 0.4, then the probability of failure would be just 0.6, right? Yeah. If it's 40% chance to succeed, then 60% chance to fail. So that's why it's 1 minus P. So you would write this one as 1 minus P. And then what's the power? This is the tricky bit. What's the power of this one? What do you think, Peter?
Power.
If there are x successes.
So it's like total trials, take away x.
Yes, very good. So that's n minus x. That is the general formula for the binomial distribution. Make sense? Yeah? So you can actually interpret the formula, right? It makes sense. Now, using this...
Is that in the textbook?
Yes, it is. It is in the second page on the sheet. And it's also in the formula sheet, I'm pretty sure. But you need to get to the point where you don't need to use the formula sheet for these things.
Yeah.
You just use it to check if you really like blanking out in the exam. But otherwise, yeah, you have no time in the exam to look at formula sheet. Did you look at the formula sheet in the last exam? No, exactly. You had no time. Right? Okay.
I feel like for my exam, they have more marks in the tech active. Like more important marks. They don't have like 2 marks question. They always have like 4, 5 marks questions.
I see. Was it like one session?
One section? Which means one section?
Like you just sit down, do tech free, submit it, and then do tech active.
Yeah.
Oh, okay. And what's the total time? 2 hours?
2 hours now.
Oh, okay.
But they reckon to finish the tech free in like 15 minutes and tech active like 110.
It's not many questions. I would prefer them to do like 2 separate exams, but I guess that's how it is for Unit 3. Okay. Anyway, okay, let's have a look at this example here and see how we can apply the general formula to do this one. Find the probability of obtaining exactly 3 heads. So now we know what's the success scenario. Get a head, right? When a fair coin, that is important, is tossed 7 times. Okay, so what does it mean? Exactly 3 heads? It means the number of success. Yeah, and I need to note this one down. X is the number of successes. Okay, so the number of success, X equals to 3, right? Fair coin means what? Probability of success is 1/2, right? Because the chance you're getting ahead is 1/2 for a fair coin. If it's a biased coin, it could be like 0.6 or 0.4 or whatever. Bias means it has been tampered with and people have done something to it so that the chance of getting ahead is like, for example, imagine a coin, they put a bit more weight on one side. So when you flip it, it increases the chance of getting ahead. For example, right? That's a biased coin or unfair coin. Okay, so a fair coin, it means the probability of success is 1/2. And then it's tossed 7 times. This means that the number of trials is 7. All right, let's plug them into the formula. X equals 3, so probability of big X, capital X equals to 3 is equals to, and then half number of trials, 7 trials, 3 successes, right? Probability of success is 1/2 raised to the power of number of success, which is 3. And in this case, the probability of failure is 1 minus 1/2, and that's just simply 1/2 as well, raised to the power of 7 minus 3. Right? Yeah, because 3 successes means 7 minus 3 are 4 failures. All right, so you can instantly get this one to 4 failures. So note that these 2 numbers always add up to 7. Right, to the number of trials. Yeah, it has to be accounted for.
It's a pattern. Yeah, I see.
Yeah, and after that, just you just need to simply work this one out. In a tech-free scenario, you have to Pascal triangle this. All right, let's say tech-free. If you see 7 trials, it could still be tech-free. Technically, they can do tech-free up to 10 trials because you can build the Pascal triangle to 10 levels. But if you have like 20 trials, normally it's the tech active one. It's just too much. Right? They won't ask you to do 20 rows of the. But I've seen people asking the students to do like up to 10 rows of the Pascal triangle. So 1, 2, 1. All right, Peter, read out the next row of the Pascal triangle for me.
1, 3, 3, 1, 1, 4, 6, 4, 1. Oh, next 1.
Yep, get all the way so we can do 7, 2, 3.
1, 5, 10, 10, 5, 1, 6. Oh no, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, 1.
Okay, all right. Now, what is the answer for 7? Choose 3.
7. So the 7 is right there. So it's 2.
Wait, we're looking at this last row, yeah?
Yeah.
What's the answer? How many ways are there to select 3 out of 7 options?
2.
No, not 2.
Oh.
It's one of these numbers. Remember, the first one represent what? 7, and you choose how many?
3.
No, 0.
Oh, 0.
right? And the last one will be 7 choose 7.
Oh, yeah.
That's why, right? If you don't want to choose anything out of 7, there's only one way. It's all incorrect.
Oh, that's 35.
It's 35, yes. So this would be 7 choose 1, 7 choose 2, 7 choose 3. So this is the one that we want. Right? So the answer is there are 35 ways of doing that. Okay, so that would just be 1 over 8 times 1 over 2. Okay, so then that would be 2 power 4. So that's 1 over 16.
Yeah.
Yeah, so that would be 35 over, I think power 7, that should be 128. Yeah, so this is the probability, and then they want to correct it. So when you see corrected 4 decimal places, technically is a calculator question, but I just want to show you guys how to do this one without the calculator. So this one to 4 decimal places would be 0.2734 to 4 decimal places.
Yeah. Understood.
Make sense?
Yeah.
Yeah. So that's how you apply the formula and then the Pascal triangle in order to do these questions. Tech-free environment.
Yeah.
Okay. Let's try a question or two, and then we'll take a short break. It's already been. We'll keep going a little bit more. So, okay, let's see. Tech-free. Okay, actually, for now, consider these tech active. So, get the calculator out. You need to use the calculator to find the NCR thing. So you don't use the Pascal's triangle for now.
Which one is it?
So in your calculator, it is, I think, let's see. Is it? I think start. Wait, this nominal. Yeah, I think at this point, hang on. There should be. NCI, I can't remember. There is a faster way to do this on the calculator. That's why I don't normally use this method on this calculator.
That one does, right?
Yeah, that one does. But normally, if you actually have a calculator question, there is a much faster way of doing it in the calculator. I'll just show you guys the faster way first. Okay, so for these questions, I want you to write down in using the formula and then use the calculator, the faster way in the calculator to just get straight to the answer.
Yeah.
Okay, and it looks something like this. Okay, this is what you do with the Casio one. All right. Okay, go to statistics, option F5, and then you want the. Okay, hang on. Not actually, we haven't learned this one yet. It's this one here. Okay, it's this one here. So statistics. Same thing. Yeah, okay. So option F5, and then you go to the distribution, and then choose binomial, and then binomial probability distribution, BPD. So all the other stuff, I'll show you guys how to do that later. It's basically that option there, right? Binomial probability distribution, and then you enter the values in based on the screen. So it looks something like this. If you go to options, statistics, distribution. So have a look into this one, distribution, right? And then binomial PD. So actually no, I think actually easier to go to statistics. Yeah, no. I changed my mind. I'm going to give you guys a special, the one that's not from the textbook. Okay, so menu, right? Menu and then 2 for statistics. Okay, so yeah, so Peter, have a look. So menu and then 2 for statistics, right? And then go to distribution, DIST, distribution, and then click on binomial, right? Binomial, and then choose BPD. BPD. So this one stands for binomial probability, right? Probability distribution. Okay, and then after that, so in the data, have to change that to variable. So click on var. Yep. So change the data to var. Right. Select that. Okay, and then they will ask you for X number trial and P. Just literally follow the answer. Right. Follow the thing that we found earlier. So you see, you go to X, enter 3. And then number trial is 7. Yeah, and then P is probably success is 1/2 or 0 point. Yep, and then that's it. Go down to execute. Yeah, 0.732734. Okay. Cool. Yeah, so that's the easiest way of using the calculator. You just need the 3, because binomial distribution, you just need the 3 parameters. How many successes? What's the probability of success, and how many trials? And the calculator just needs to ask you for those 3, and then you can just spit out the answer straight away.
Yeah.
Okay? Okay, so let's try an actual question. So let's try question 2. So for these ones, I still want you to write the formula, like apply the formula, write it down before you actually put into the calculator to get the answer. Okay, so I'll walk through this one, and then you can try out the next few questions. So it looks something like this. Similarly, exactly 4 heads, right? Fair coin, toss 7 times. All right.
X is equal to 4, right?
X equals 4, yes, just list down the things. So fair coin, probability of success is 1/2, and then number of trials is 7. So then we want probability of getting 4 successes. That will be equals to 7 choose 4 times by the chance of getting a success raised to power 4 times by chance of getting failure raised to power 3.
Yeah.
Right? And then using GC, that would be equals to, and now you just follow the same steps. Right? So menu statistics.
7.
Yeah, and same 0.5. So it will be the same, 0.2734. Yep, that's still the same answer. You'll see why that's the case in probably maybe when we are almost through with this chapter. Okay, make sense? So that's how you actually write the answer for that. So Peter and Stephen, if you're listening, grab a piece of paper, work out question 3.
Tech active.
Tech active, yes. Consider all these tech active for now. The tech free stuff we'll practice closer to the exam. Remember, you need to write exactly what I wrote for the last question. Yeah. So practice writing those, because writing that will give you the mark for the question, for the working out in the exam.
I just realized, like, I did a lot of math for the last unit. It was like a whole book and probably some more, because I did some more too. So in my school, it's like a really big book. It's like that big. Like this big.
Wow.
Pretty much. Yeah.
And you finished that entire book?
Yeah.
Damn. Alright, that's good.
And probably some more, because I did it materials as well.
Yeah, hopefully the result is good. Hopefully.
Yeah, hopefully.
Do you know anyone who finished the entire paper?
Yeah.
Yeah, of course.
But she was like genius, no?
Oh yeah, of course. There will always be someone. Yeah. Alright, so try question 3.
Because this one is 4 successes. How
Yep.
can I do it?
4 successes. So
4 and 0.
no, 4 and 4.
4 and 4?
Oh,
Yes.
you mean the power? Yeah, 4 and 0. Yes, it is 4 and 0. Yeah, so normally you, if it's like doable, you should convert that into decimal. Yeah, 0.0016. Okay, now I'll explain my answer a little bit here. So a little bit different. My answer is just 0.2 power 4. Why is that the case? So even if you were to do the other way, which is 4 choose 4, and then that would be 0.2 power 4, 0.8 power 0, right?
Yeah.
Anything power 0 equals 1. So that just be 0.2 power 4 times 1. And how many ways are there to choose 4 out of 4? Only one way. Right? So if you have 4 successes and then 4 trials, there's only one way. Which means you can go straight to, and that only one way would be to have a success times a success times a success times by another success, which is just 0.2 power 4, right? Similarly, if you have a scenario with like 0 successes, right? 0 successes would be just failure times failure times failure 4 times. Does that make sense? There's only one way, right? You either fail 4 times, you succeed 4 times, that's it. There's no way to rearrange like that. Remember the tick before, you can't rearrange the tick, right? There's all 4 ticks, or the all 4 crosses. There's no way to rearrange them. There's only one scenario. Okay? And that's why in the special case, that's why in the Pascal's triangle, you see how it always starts with 1? Yeah? 7 choose 7 is 1. There's only one way. 7 choose 0 is also only one way. And the first one would be 4 choose 0, 4 choose 4. Right? So this one would be 4 choose 4, and this would be 4 choose 0. Yeah? So that's why it always starts with 1. There's only one way to choose nothing out of the scenario or choose everything in that scenario. So that's why when you see these kind of questions, sometimes in the exam, in the tech-free especially, if you get that, it's easier to calculate than trying to get this, because then you might need to think about what's the Pascal triangle answer for this. Unless you realize that, oh, hang on, that's just only one way. Then suddenly you just get straight to the answer. Okay? Okay, so yeah, so those are the easiest two, those are the easiest 2 examples for this one. Then, okay, we'll take a short break. I'll pause the recording, we'll take a short break. After that, I'll go through the next half of this chapter. Very important, and that is about the binomial cumulative distribution function. Yeah.